Hi and good morning. We're from BEZ. Today we will present our project assignment vertical oriented, which is application of digital electronic.
The group consists of 4 members, which is
It's me, Muhammad SYAQIR bin ABDUL HALIM.
me, Muhammad FIKRI bin BORHAN, THEVAPRASAN anak lelaki SARVANAN, lastly HASBULLAH bin HAIRUDIN.
Our objective of this project is to give a chance to students to apply in practical on what they have learned during the class to further deepen their understanding.
Second, to expose the student to use of many kind of sources in gaining a knowledge and information.
Next, our objective is to develop the skill of critical thinking and problem solving, as well as communication skill and teamwork spirit while doing the project. This is our Gantt chart for this project. First, our task is problem discussion. Duration is took 1 day, which is start 24 October. Then our task division is the duration is 1 day, which is start from 24 October. We have divided the work to 4 tasks, which is the report is done by THEVAPRASAN, then the simulation is done by Muhammad SYAQIR and Muhammad Fikri, and then the slideshow is done by HASBULLAH. Then the third task is project progression. We took 9 days to complete this task, which is start from 25 October to 2 November.
After that, the report progression task is take 2 days and start 2 November until 5 November. Then final check duration is 1 day, start in 6 November, and presentation take duration is 1 day, start in 7 November. Lastly, project submission is 1 day and start at 5 January. This is our Gantt chart for this project.
Our project is water quality detector. This is our problem statement for this project. Most of the people that own a big mansion or big backyard tend to have a swimming pool. It is not easy to maintain the sanity of a swimming pool. Swimming pools tend to get dirty pretty easily. In a country like Malaysia, with high level of humidity, algae can easily form in swimming pool. Other than that, it can trap all kind of garbage in it.
Moreover, chlorine plays a big part. Low chlorine level will ease the growth of germs and bacteria. High chlorine level and damage the human skin. In order to overcome these problems, an alarm system is needed to alert the owner whenever the pool is in a bad condition.
So this is our truth table. We have 4 input, which is water, chlorine, garbage and algae, and the output is X, which is alarm detector.
So according to our project, the water will always be high, which is 1. So the alarm system will only detect the chlorine level, the garbage and also moss. So according to our truth table, whenever the chlorine, garbage or moss is 1, the alarm system will be turned on high.
Yes. So based on the truth table, we get our Boolean expression, which is we only see the high output. So we get A B bar C bar D plus A B bar C D bar plus A B bar C D plus A B C bar D bar plus A B C bar D plus A B C D bar plus A B C D. Next, we go through the multisim.
So as we can see, this is our logic circuit. So now we will demonstrate how our logic circuit works.
Yes.
So this is our logic circuit. So the water will always be high, which is 1. So when the
chlorine switch is on,
when the chlorine is detected, which is 1 high, the alarm system will turn on. If there is any waste in the water and it get detected,
it's also on.
on, and if there is algae, the alarm system will be on. So whenever it detects any high level chlorine or low level chlorine or waste or any type of algae, the alarm system will
is on.
So after this, we'll see our game map.
Based on the Boolean expression, we use chem map to simplify the equation. So this is our chem map. After we simplify the truth table, we get AB plus AD plus AC.
So this is our simplified Boolean expression. If we see our K map, we have 3 circles. So the first circle stands for AB, and the second stands for AD, and the third stands for AC, which is equal to Z. So next we will take a look at our simplified logic circuit.
So this is our simplified logic circuit. Based on the equation, simplified equation, we only use 3 AND gate and 1 OR gate. So water level is always high. Chlorine, waste, algae, if any of this is high, the LED alarm is turned on.
So now we will take a look at our simplified logic circuit. Okay, so this is our simplified logic circuit. It consists of 4 sensors, which is water, chlorine, waste, and algae. So the water will always be high. Okay, then according to our Boolean expression, we used 3 AND gates, which is
one of 2 input is 1.
If any of the input if both inputs are on,
Yes.
it will turn on. And it also consists of OR gate, which will turn on if any of the inputs are high.
Yes.
So as we can see, if the water is high and then the chlorine is high, the LED will turn on. If the water is high and the waste is high, the LED will turn on. And if the water is high and the algae is high, it will turn on. So as I said before this, whenever there's any detection of chlorine, waste, or algae, the LED will turn on. So now we proceed to the next
3D
slide.
circuit.
3D circuit. So we used multi-sync to build this 3D circuit. As you can see, it consists of 4 switches, 2 ICs, one for AND gate and one for OR gate, and lastly an LED. So now we will pass on to our team members to finish off the slide. Thank you.
The operation of the circuit is, the first is every single AND gate will be connected to its respective sensors. Secondly, the output of the AND gate is connected to a 3-input OR gate. Next, the output of the OR gate is connected to the alarm. Then, if all the sensors are low, the alarm will not be set off. And then lastly, if any of the sensor is high, the alarm will be set off.
The conclusion of this project, the water quality detector provides an easy way to detect any impurities in the swimming pool. The sensing is done by 4 different sensors that detects presence of water, object detection presence of algae, and level of chlorine in water. We can conclude that this system is very effective and beneficial for the user. The system is pretty flexible. It can be used in other applications. For an example, water tanks, water dams, and big-scale fish tanks. Finally, at this end of this presentation, we would like to thank to our lecturers, fellow friends, and group members.
With their helping hands, we are successfully completed this assignment and can understand the project and can relate to theory that we have learned. That's all from us. Thank you.